Let's talk about avalanches. And this is a photo of one that I was in 2013 on Mount Washington.
So I've dug a little hole out here in the snow because I want to show you all of these different snow layers that we have, and then we're going to talk about what that means. So I cut out a little square here in the snow, and it's a little over a foot thick despite the amount of snow that we've had. But what I want to show you is all the different layers. So we're going to brush the snow off of this. We have some ice here. We're going to go ahead and feel very gently where there's soft powder in between here and how deep that is, and then there's another ice layer. Let's see, we're going to go ahead and feel along. And what we can do is actually clear out, frankly the top layer is pretty fragile, different layers of snow and ice, and actually reveal kind of a history, almost like geology, where we've got hard, crispy layers, fluffy snow, more ice layers, fluffy snow, just layered one on top of each other. I mean, this is an incredibly thick chunk of ice right here. Looking at these layers just tells an incredibly cool story and a cool history about what's happened with the snow. Because you guys know the difference between all the different winter precipitation types, the sleet, the freezing rain, the snow. You guys know the different types of snow we can have. We can have needles, we can have plates, we can have dendrites. Now you get to know a lot more about avalanches. You see, there's a third type of snow called blowing snow. That blowing snow is another layer upon everything where you have whatever fell, whether they were dendrites or snowflakes or whatever you had, are falling and tumbling and breaking and create another type of snow altogether. All of these layers act very different.
Blowing snow is difficult because the colder it is, the more fragile the little dendrites become, and the more likely you are to get wind transport and wind loading on mountains and on snowy areas. This wind loading is incredibly dangerous because it points to really dangerous areas on the mountain. And that's because these different layers of snow behave very differently, especially when under pressure and you have layers. So think about layers of light fluffy snow as almost ball bearings, and think about these ice sheets. Now what were to happen if you get an ice sheet on top of a layer of ball bearings and somehow it breaks loose? What's it going to do? It's going to break away and it's going to slide. In its simplest form, this is exactly how avalanches work. So I found a spot on a hill just to demonstrate to you exactly how that happens. For some reason, whether it's a skier, it's a hiker, imagine they come along and disrupt that top layer. Look at what happens. That is an avalanche, and that is, once again, at its most basic layer, how avalanches happen. Now, I'm also going to have a little bit of fun with this. Whee! Because why not? We're learning science, people. We are just scratching the surface about avalanches, no pun intended. If you want to see more about how they test for the avalanche danger in the mountains, if you want to know about the different types like wets and slabs and dry and cornice and all this kind of stuff, post a comment below and maybe I'll do a follow-up going into more detail on this. Also, for more information, especially if you're located here in New England, go to mountwashingtonavalanchecenter.org. They have phenomenal information. Plus, it's information you need to check before you go out and play in the whites this winter season.